Ok, trovo. E condiviso, fatto con la condivisione.
Sì, della Microsoft.
E quindi avvia.
Nice. Morning, everybody, and welcome to this Open Data Science Open Day. I am the coordinator of this Data Science Masters program, so welcome to this event. My name is Francesco Rinaldi, and I'm here to give a small presentation at the end related to our master's program, together with another colleague, Tommaso Ersege, that will introduce you to the internship program that we have here in our master's program. But I don't want to waste your time, because we'll have enough time later on to discuss about this part. Then I will just leave the room for our first speaker that will discuss about some data science applications that he met in his everyday life. So welcome, Enrico, and thanks for being here today. Yeah. And you can start when you want. Yeah.
Good morning, everyone. Thank you, Professor Rinaldi, to invite me today. And I'm not so expert here. Oh, yeah. Okay, I am Enrico Vicario. I am an information engineer. I studied here in Padova many years ago, and now I work for the company Microtech, and I am in the advanced research team, so I am sort of researcher for the company. In the past year, I developed a product for the company. I installed product all around the world, basically a scanner for measuring the wood industry. I had some publication and patent with the company, mainly on the topic of X-ray technology and computed tomography. And in the last year, we had in the company many students that decided to have the master thesis with us or an internship, and also I had the possibility to follow some of them. And I started 3 years ago an industrial PhD with the math department. My supervisor are Professor Rinaldi and De Giovanni. Topic of this industrial PhD is the optimization in the field of wood industry, so apply some state-of-the-art algorithm and try to use also deep learning approach for this type of optimization. 2 words about the company. The Microtech was founded in 1980 and grew a lot. Now we are more than 400 employees. Turnover of the company is 75 million euros, and the important thing is that 15% of this turnover is invested in the research and development. It's a company that operates worldwide, and I can say that it's a leader company in the wood scanning solution. This is a nice picture of the headquarters in Brixen, Alto Adige. And as I told you, we have world extension of the company. So we have the main office in Brixen. Close to here, there is the office in Venice, where I work usually. And we have an office in Vancouver, in Canada, Corvallis, US, office in Sweden, in Finland, and in Germany. Maybe we have to press this one. Okay, I have a very short mode. Push.
Devo ricondividere perché non si vede. Grazie. Presentazione. Da caso non vedevano. Quindi adesso dovrebbe andare. Sì.
Okay, this is a short movie that in 1 minute. Sorry, yeah, some problem with this. So this short movie is show how is the environment of the sawmill. So you see the log yard, so where the logs are arrive and logs are put into the saw line. This is a scanner that do a X-ray measurement of a log. The logs go into the process line. This is a operator that follow the process of the line of the logs, but the line is automatic. So we have a measurement of each single logs with the defect. We have another scanner that identify the logs and decide which is the best alignment, the best solution to recover the best value from this log. So try different cutting pattern, and after this log is sent to the cut line where the log is rotated with this roller. So I'm not so precise, but trying to perform the expected cut scheme. This is cheaper, but do the external cut, and after we have saw that are move automatically in order to perform the exact thickness. Board go down on the side, and then the log is processed, and at the end of the line we have sharp board with an expected quality. The goal is to obtain a good quality out of these logs. So in the top of this production chain, in this installation, we have was an installation in Germany. So this is the scanner. So this scanner is a tomography scanner that we introduced in the market 10 years ago, more or less, and it's a sort of revolution because as in the medical field, we can have a simple tomography, simple radiography of the body, or we can have a CT, computer tomography of type. So in this case, we have only one projection. In the other case, we have the full information of each single point, density of each single point inside the log. And it's the same with the logs. So in the past, we have only information, one projection, two projection of the log. This is the longitudinal direction. In the other case, with the CT, computer tomography, we can have additional information. We know the density of a log in each single point. We have one slice of this type, each centimeter full, with a lot of data that we can elaborate. What we can do with this information? We get this data, and we developed in the last years algorithm able to identify all the features of the log. For example, pit position, that is the center of the annual ring growth of the logs. From the pit around grow the branches that are initial stage are sound and after become dead. And this is something that impact the outcome when you cut the log. You have different quality in the product you can extract from the log. For example, we can extract easily split, so rupture inside the log, and other defect like a resin pocket. So what is the reason we do that? Because with all the information that we can extract from the log, we can try to estimate before the cut which is the value of this log in terms of cut a board inside the log and decide which is the appearance of the board. For example, in this case, we cut this log exactly in the same way. The top image is the one extracted from the CT data, the virtual board, and the second one is the real board that is passed to the scanner, and we collected the color picture of the board. So on the top we have the virtual defect estimated, and in the bottom we have the real board. So combining this capability to identify, to estimate the value of a board, we can do some optimization. So before cutting the log, we can try different cut solutions. So the software show an example of optimization. In this case, we have the red line show how change the value of the logs in function of the rotation angle of the cutting pattern. The blue value show the value estimate considering also the internal quality, because if you try to optimize the log only looking at the external shape as it was usually used before, you can't appreciate with different in value that the board can have if they are cut in different positions at the log. So, for example, in this position, we have a different price for the whole solution, and this is the optimal position for this log based on this cutting pattern. And you can see that we have almost 10% of gain in value. That is a lot for a sawmill. And or we can also try different cutting pattern, like in this case with a different cutting pattern that give also a higher price. But it's something that can be possible only if you know in advance what is inside the log. And this optimization is not easy because we have a lot of degree of freedom to do an optimization in a log. We can have different product, different orientation, different combination of the product and the cutting pattern. The logs are cut following a curve, if possible, and also give a correct value of a single board is itself another optimization, because in one board you cut from the log, you can extract a different product, small product, or also product aligned different way and in the same board. This is a schema of the saw process. So logs arrive to the sawmill, and normally we have long logs that are cut in short logs based on normally on shape, on dimension, diameter, and on quality that is given by the operator. And normally logs stay in the log yard for maybe 1 week, 2 weeks, 1 month. The logs then are taken and put on the saw line to produce a board. The board are stacked, and after again some time, 1 week, 2 weeks, the board are moved to the drying room where they stay for some days in order to reduce the moisture inside the board and obtain the final product. Final product that is measured again and probably profiled and cut, trimmed. So during the process from the log, we arrive at the final product that is the board. Microtech in the last 40 years improved continuously the possibility to scan on each step of the logs, the board, the final product, in order to obtain the best possible solution locally when we have this scanner. But in the last year, and the work on the next year too, is to consider the saw line process as a smart factory. It means that we combine all the information that we have on each step of the production. So we develop a system, that are able to track and to make a connection from each step to each other step. For example, when the logs arrive, we measure the log with the CP log, and using the internal characteristics of the log, we are able to create a fingerprint, so to associate of this log. So when this log is moved to a saw line, we have another scanner that identify and recognize this log between the millions of logs that are outside already scanned and with already a solution. So we can optimize a log and the log stay there in the log yard. And we know already what we are going to cut on this log, but this log will be cut maybe 1 month later. So this allows to have a different management of the sawmill. And when the log is cut in board, we recover the solution. We have system that move the log exactly in the angle, in the position where that was talked before. And also we have a scanner that identify which is the error of a cut, because the cut is not precise. So how the logs is moving the soil, so it cannot be really precise. So we create a fingerprint or the scriptor also for each single board. Each single board is stored, is dried, and after the board again arrive the final stage, and the board is again recognized between the millions of boards that were cut before and that where we associated fingerprints. So, and we are in the field of big data because you can imagine big sawmill kept up to 10,000 logs for each day. For each log, we have 10, 20 boards. So, and customers start to asking us to store 1 year of production, 2 years of production. So you should be able to store in database a lot of information. For sure, we can store the original city data. That is a very huge amount of data, but at least all the model of the logs, the knots, the defects, the cut solution is something that can be easily stored. What we decide to cut, what was really cut on the logs, all the board, the model of each single board, the optimization of each single board. And this really allow us to do a lot of things with this data. And for example, you can have a virtual stop in the log or the log with a decided optimization. You can re-optimize some log and verify what happened. If you re-optimize on the log, you have a completely different production. So this, which analytics are enabled if we can do this full traceability and have data to do simulation. For sure, we have a more accurate evaluation of the raw product. That means that we know for each single log which are the board at the end that are produced by this specific log and which position. So we know the forest that produces this log, and so we can do the correct value for the logs. We can pay the correct price and do some management of the forest in a way more accurate. The sawmiller can do some different strategy of production with the possibility to do some simulation. It's possible to do some evaluation of the impact to have a new product that normally a sawmill maybe doesn't produce, and adding this product with simulation of the data you already store, you can have an overview, an estimation of what, how this will impact your current production. You can more control of your planning, daily planning of your production. You can apply some algorithm to verify critical things regarding the maintenance of your machinery, or verify if you have deviation for the standard weight, standard status. And last thing, also important, is the possibility to do some cross-training between scanners. For example, we have a board scanner that is very good in identification of the defect on the board, and having the possibility to use this data and associate this data to a original city data of the log, for example, we can do some training using deep learning without the necessity to have a manual leveler that continually mark picture to define what is a defect, what is not, because automatically we can create a huge data set for this. Okay. Thank you. I hope I give you an overview of this quite huge work.
Thanks, Enrico, for this presentation. To explain how big data help you guys in your everyday life. So if there's any question to Enrico, we have a couple of minutes. Otherwise, we will switch to the second speaker of the day. Question or remark? So thanks again, Enrico. Second speaker.
Provo in caso. Okay.
So, welcome, Luca. Thanks for being here today. So I'm very glad to introduce our second speaker, Luca Pasa, from the Department of Mathematics. He works on machine and deep learning, I would say. So today we'll talk about some very cool machine learning applications that they have in their everyday life, right? So.
Okay, thank you. Thank you, Francesco, to invite me. Today, basically, we'd like to discuss with you about what means using machine learning in data science and which is the role of machine learning in data science. So, okay. Okay, let me spend just a few moments to introduce myself. I'm an assistant professor here in the Department of Mathematics. I got my master's degree here. At that time, there weren't the data science master course, so I attended the computer science one, and there were basically 3 curriculum, and I chose the artificial intelligence, and so basically my interest in machine learning grew at that time, and so I decided to attend also a PhD here in the Department of Mathematics under the supervision of Professor Alessandro Sperduti. And at the time, basically, I work on deep learning applied to sequential domains. Then, when I finished my PhD, I decided to follow the other interest that I had, that is about the application of machine learning in neuroscience. So I decided to join the Center of Transactional Neurophysiology, Speech Communication in Italian Institute of Technology, where basically I apply and I use my knowledge that I acquired in my PhD on speech and communication tasks related with the human interaction. And finally, I decided to come back here to start to work on theoretical side of deep learning, basically applying on graph structural data, which is very interesting right now since we had thousands and thousands of data sets related with graphs. I am also part of a machine learning group, which is a group here in the Department of Mathematics that basically work on machine learning and deep learning. Here, I leave our website if you're interested in our works, and also report some research line. As I said, one of the most interesting for me is machine learning for structural data, but we also work in several applications of deep learning on psychological science, knowledge representation, fact design, and also on different learning paradigms like active learning and continual learning. So, why I'd like to speak about machine learning in data science? Basically, I don't know if you are already aware about that, but in data science course, there are 4 different study plans. All of this involves some machine learning courses. The reason why that's happening is basically because the relation between machine learning and artificial intelligence in general and data science is twofold. On one side, basically data science use machine learning models and techniques to extract information as a tool. But on the other side, the rise of data science and the interest on data science that we had in the last few years basically drove many players of the market in saving and storing tons of data. And this data allows deep learning scientists in obtaining better results, and we had also the possibility to develop and use models that require a lot of data to be trained. So the connection between machine learning and data science can be also found in definition of machine learning. I just report here some of the definition that you can easily find on the web, and I would like to discuss this definition with you. Basically, first one say that machine learning leverage on data, which is basically I like the fact that machine learning is totally based on data. So having a good data, a lot of data is necessary to obtain good result in machine learning. In the second one, the second definition, this one, say another important, another important points. The ingredients of machine learning are basically 2, the data and algorithm. So if you are able to write algorithm and have a lot of data, you can obtain a machine learning model and use it to perform any data extraction or extract information from data as you prefer. The third one said another interesting point, which is that machine learning is useful in a very peculiar scenario, which when you are in a situation where you have to write an algorithm to solve a problem, but you are not able to do it because the problem is too complex. So you can use machine learning and use data to find a solution. So the algorithm basically find an algorithm that solve your problem. And this research and solution is totally based on data. The last one is a bit more complex definition, but I would like to report it because it basically gives an idea what learning means for a computer program. And it says that a computer program learns from experience with respect of some class of task T and perform measure P. If it is performance in task P as measured by P, improve with experience E, which means that we can talk about learning when we have an algorithm that, given more and more data, improves its performance. So in this case, it's clear that having a lot of data and have data that is good for the task that we want to perform is crucial to obtain good results with machine learning. This is just a timeline of what happened in machine learning area. I don't want to speak about all the stuff that these guys invented and developed in the last 50 years, but I would like just to tell you 2 points. First one, machine learning is not new. The idea of machine learning arose in 40s, so many years ago. But the point is that just after 2006, we had significant rise in the interest of deep learning. The reasons are basically 2. First one is that these 2 guys, Hinton and Aslan, develop a very convenient and powerful way to train very complex machine learning model. The second one is the introduction of the GPU and parallel computing in machine learning. So basically, we had the possibility to train finally very complex model and to apply it on a lot of data. And the third reason is the availability of tons of data that start in the last 10 or 15 years. Nowadays, machine learning is basically applied everywhere. It's ubiquitous in our life. In the last few years, you can find it easily in your phone. On Google Maps, basically using a machine learning algorithm to compute how much it's going to take to drive from a point to another. It uses in driving, in recognizing object, on speech recognition, when you use Alexa or other assistant. In the past, it's applied on some game like chess, for instance. Deep Blue is quite famous application. Nowadays, it's also possible to apply it on more complex games like Go, or also strategic video games like StarCraft. So the improvement in terms of capability of this algorithm is incredible, in my opinion. Considering also the small time passed from the application on game like checkers, that is quite simple, to what nowadays we can do. So I said several times word like machine learning, deep learning, but I would like just to introduce the concept of machine learning and deep learning. Deep learning is basically a word that hides what really discussing about, that is basically artificial neural network, deep artificial neural network. Artificial neural network are just a model inspired by how our brain works, and the building blocks, the main building blocks of this model is an artificial neuron that basically try to mime what a real neuron do. A neuron obtain data from other neurons by using bandwidth, and perform some type of processing, and then send the result of this processing to nearest neurons by using the axons. And artificial neuron do almost the same. Basically, it has some input from neuron around it, compute some kind of mathematical transformation of this data, and finally return the result and send this result to some other neuron. A neural network is basically an ensemble of this neuron, and we're talking about deep learning. We are just saying that we organize these neurons in a very particular way, basically layer by layer. Why layer by layer? I found this intuition, this explanation of the intuition in a deep learning book that, in my opinion, is quite interesting. So imagine if you have to explain some concept using concept that you already know, so simpler concept, and you want to draw a graph about this explanation. Basically, the graph that you obtain is a deep graph with where some concept are used to create or to define more complex context. And this graph will be deep with many layers. And for this reason, we call this approach deep learning. Basically, that's the idea. So as we said, the deep learning basically requires a deep artificial neural networks, lots of data, and fast GPU computing in order to obtain the result in a decent or acceptable time in general. What does it mean, a lot of data? Just to give you an idea, many years ago, a researcher wrote a paper discussing this point. And he said that in order to achieve acceptable result for a deep learning model, you need at least 5,000 examples per category. What does it mean? Imagine that you have to create a deep learning model for the side if a sentence is true or false. So basically, you have to perform a binary classification task. You need 1,000 examples. And this example has to be labeled, so it's very complex. If you want to achieve a result that is comparable to what human can do, and in some kind of problem is possible, you need 10 million of label examples. So you need a lot of data. Okay, I would like to finish this brief presentation by telling you about some project that we are did and we're still working on here in Padova. The first one, as I said, is related with sequential domains, so sequential data. Basically, we apply this kind of recurrent neural networks or network that basically have some kind of memory and that receive at each time step a part of the input. Imagine that you have to classify this sentence. Imagine that your model receiving input every time a word of your sentence, and at the end, you basically will be able to understand which kind of sentence you are giving input to your model. That's the idea of recurrent neural network. We apply this particular model on many different scenarios. One of these that I would like to show is the application of this network on speech enhancement. Basically, imagine that you are in a crowded place where many people speak at the same time. So it's quite different to understand what speaker of interest said. For human, it's quite normal. When we are in a public, we do it every day, basically. But for machine learning, the model is not that easy. In this project, we basically try to mine what our brain do, basically using some information about the movement of the space or speaker of interest. So we have this crowded place where many people speak at the same time, and the information about speaker of interest related with the movement of his face, and that's the result of the audio works. So you have these two speakers that stick together. Now we take the information about one of this speaker, the one that we want to extract, and we can extract what the speaker of interest said. We have one more example, but basically at the same situation. Very difficult to understand what they said. And the model can extract the voice. It's possible to do it also with 3 speakers. We can generalize with even more than 3 speakers, but as an example, with the speaker is even more noisy, the situation. And we can easily extract this part. And that's just one of the many applications that deep learning enables nowadays. Another topic that we are very interested in is the application of this model on graph, as I said. the first slide. Okay, it doesn't work. Okay, the first slide, sorry, too fast. Okay, the application of the model on graph data in this kind of data that basically can be drawn like this thing, so many nodes related to the other. Graph neural network is a model that we apply, basically that is a method that exploit the structure of the graph and the connection between nodes also to perform some kind of task or whatever. We apply this kind of model in many different tasks related to informatics, for instance, fancy structure property relation that basically require to extract some or to detect some property related with some components, find the structural similarity between compounds, and so on. We also apply it on social network, which quite obviously is a nice source to big data nowadays. Also for forecasting speed, volume, or density of the traffic, that is basically what Google Maps already do. And recommendation system, I think we all use Amazon or at least some eShop methodology that suggests us which will be our next purchase, and basically it uses some recommendation system that is basically use some graph neural network. So what we are doing as a machine learning group, basically we are developing new model that try to improve the accuracy of the nowadays state-of-the-art model. We try to define it in order to obtain a model that have a very high computational efficiency, because obviously nowadays it has to run a very cheap devices like your smartphone, for instance, and it has to work quite fast. And finally, we are also interested to develop models that are biologically plausible. What does it mean? We like to apply this idea of graph neural network on neuroscience, because basically the way that we think, the way that our brain is structured is related with graph. So applying this kind of model in neuroscience is very, very interesting. We are working on it very, very hard right now. So basically, that's my presentation. I would like to thank you for that.
Thank you, Luca, for this interesting presentation. So if there's any question or comment for Luca, feel free to ask. Join this discussion. Any question or remark? Well, if not, then let us thank and now we switch to the second part where you guys should interact with the data science students that we have here today. So we should welcome now our two students. There is enough room for both of you. One can sit and then we can talk.
You can start first.
I think you can start because you have a presentation, and then we switch to second one. So we have our two students, one from the first year and one senior student, because he's going to defend his thesis in September, I guess, if I'm not wrong. And they will talk about their experience here in Padova. And
sorry.
So this was a surprise. And so they will talk about their experience here in Padova. So guys, I suggest you to ask them a question, as many as you want. And I'm pretty sure they will really glad to answer to your questions. So we will first start with the senior student, and then we'll switch to the first year student, the young one. He will describe a bit his experience in this first year here in Padova. And while Guriet, he will describe a bit also the experience he had in the Erasmus project and program, and the experience he had with the internship and the thesis.
Right.
So thanks guys for being here.
I'm not sure if, I think I stopped the sharing
stop the
screen.
sharing, so
Right.
I have to share. Thanks for
Does it
reminding
work?
me this. Let's see.
I never did a presentation. So.
Okay, let's share the screen. Yes, this one, right?
Right.
Sure. And it should be good. Okay. Next start.
It doesn't. Okay.
Should
I think just for the PowerPoint, right?
And you should point toward the.
Okay. Hi, everybody. So I'm Gurjit, last year of data science. Hopefully, I'm gonna graduate in September, or let's see how the research does go. But I'm also part of Machine Human Intelligence Research Group in Helsinki. I did an exchange there, and so I just came back for you guys. So, no, okay, right. It was a little bit slow. Sorry. Okay, just a bit of me. So I born in Punjab in India, but I was 2 years old when I came here. So I was a little chubby kid when I came in Italy. I live in Verona. I spent 2 years at CERN working as a software developer. Then I realized how much things we can do with data, and we can make a lot of inference. We are living in a big data era, we call it, and we do a lot of by analyzing it. We can make decision, like optimal decision. And yeah, I mean, at CERN they collide particles there when they collect like petabyte of data in one day. So a lot of things, we make a lot of data, apparently. And so it's a good investment in data science, I would say. Then, okay, so I wanted to invest more in education. So I started a data science program here in Padova. I found it pretty nice. I'm very happy with that choice. And I also did an exchange in Helsinki for Erasmus exchange. And we will see later, but I also joined a lab. So my top 5 of Padova and UniPD. Well, Padova is a student city, very vivid life, I would say. I was missing a lot Geneva because it was really international. I found here people from America, like in our last year, we had people from Germany, South America, there was a guy from USA, then a lot of Iranian people, Pakistani people, Indian, and yeah, here you go. So it's quite, it's a well-structured master course, so you have a lot of choices. And right, so it's a good trade-off between like theoretical content that you would really need and the application part. So yeah, you have not just exams, luckily. You have also practical group project. So you make teammates, now you talk and you deal with the problem, right? International and intercultural environment, a lot of people from different fields, like you find mathematicians, like computer scientists, biologists, and also like people from economics or statistics. And the best part, I did the exchange program, and the thesis, you have like 1 semester to do the thesis, or even more, like it depends on how actually you go ahead with the research. And it's really interesting. And you are surrounded by good people, I would say. And most like course, optimization for data science, Professor Rinaldi. And all professors are very good, like especially in the content of theoretical concept, but you also, you don't just do theory, but also you do some project, especially there is one big project in optimization for data science. So we and my friends with some couple of mates, we built some universal adversarial perturbation algorithms and federated learning. So those are kind of noise, like, for example, if you're driving a smart car, and then it's getting the data and then it's predicting there is a man or maybe a dog, but they can be fooled quite easily by finding such noise. So instead of predicting like a dog, maybe it's a person, right? And that's a huge problem, right? And you don't see, like, you don't perceive the noise by eye, but but the neural network doesn't understand there is a noise, right? Instead, we don't work in this way. So good deep learning is really good, but sometimes can be is a machine. We build it and can be fooled quite easily. With Professor Ballan, we also in machine learning and deep learning, we did a project on semantic segmentation. So you have satellite images, you want to predict which one is a building, or here, well, it was like a ground predicting if there was a man or like, so you predict if there is a man or not. What else? So you can find all this project on my GitHub. And also other courses that are really nice. Stochastic methodologies, Professor Ferrante. You have it in the first year, and it covers theoretical probability, and it's quite basic, I would say, but it can get advanced. There is also an advanced course of this. Then mathematical models and numerical method for big data, Professor Tedesco, but I think this year they changed because he was part of Gran Sasso Research Institute, and it was a really nice course too. But also you have cognition computation, which is like a course with neuroscience core master course. And this was really important for me, especially because we talked about a lot about machine learning and deep learning, but there is also another field about probabilistic modeling. And it's not just learn, we learn from data, but we also have some priors, right? And it's also quite philosophical. And yeah, so deep learning is not the only thing, apparently. And then I did the exchange in Helsinki. So there are several courses and a lot. You see, this is the university and all are my pictures that I did. But so there are some courses. I mostly follow like statistics course. I like math, sadly. But computational statistics from Professor Vijay Sadvi. You have also reinforcement learning and Bayesian machine learning, high dimensional statistics. You also have a course here and big data platform too. The organization is a little bit different. So you have one semester, you have 2 different periods, and each period you have like 3 classes, 3 courses. After 3 courses, you've done 1 period, then you do the exam or you do the assignment. There are a lot of practical assignment here. Then in the last semester, I joined Machine and Human Intelligence Lab, directed by Luigi Cervi. He does computational statistics. He's a neuroscientist. And well, what we do in this research, we develop smart machine learning. So we want to build such, probability. We mostly deal with Bayesian inference and probabilistic modeling. And we want to learn, because sometimes you don't have so much data. You have just few data. It can happen. And there are a lot of problems which are very, you think about like, even with little data, the problem, the complexity of the problem can be very huge. And so we study, and by using Bayesian inference, you make such rational agent that can interact with the environment or can make some decision by having some priors you have in your mind, and then looking at the data, and then you process maybe an optimized way to act and make a decision. There are some ongoing active projects in the probabilistic machine learning group. One is for variational Bayesian, Monte Carlo Markov chain, Monte Carlo methods, and Bayesian adaptive direct search, which I'm working right now. But so I'm supervised by Professor Luigi Cervi, and also from co-supervised by Francesco Rinaldi, professor. And Professor Rinaldi also worked with optimization problem, since he's also holding the course of optimization. And what we do is black box optimization and for non-smooth and stochastic functions. So what does it mean? Like sometimes function evaluation are very expensive. Like maybe transmitting the information from one neuron and to the other, you want to, I don't know, you have a function which describe how this information is transmitted, but it's very expensive. Like it can take seconds to evaluate. And so you have to, and here deep learning doesn't work. Like there are fields where deep learning don't work, and there we come with some other approaches, and which are called adaptive direct search, and this kind of field is really big one. And also you have some constraint about how many times you can evaluate the function. You can evaluate just 100 times. you can more. And so you really need to define an algorithm which, by just having those little data and looking at the space, you want to make it in such a way that is efficient, so it doesn't take much data. And there are no analytical access, so you don't know about the function that you have. And the usage are a lot of neuroscience, machine learning, deep learning, engineering, and many other fields. The objective is to find the minimum of these ugly guys. Right? They are really hard to get optimally, you want to have the global minimum of this function, but it's really challenging. Just, I'm gonna be not too much technical, but in this research, as I said, is black box optimization. We use some Clark derivatives and Clark derivatives calculus to approximate the gradient of the function, and we use adaptive direct search method, but we also use some Bayesian method, which is the Gaussian probabilistic models. So we use Gaussian process to define a surrogate, something that can approximate this function, and we combine this part of the Clark derivative adaptive search method and also some Bayesian method to understand where is this global minimum. And so that was supposed to be a GIF, but it isn't. So I can't, sorry. But what I'm doing right now is building scientific library in Python for bots. This is gonna be actually in future public on GitHub. So it's gonna deal with optimization problem in general. And then I'm working on how to quantify uncertainty. So sometimes you have the surrogate, you don't know how much variance is, so you're not sure that is a local minimum. How is it like a good point or not a good one? And I'm gonna start working on a multi-star Bayesian optimization, right? And thanks for the attention. Feel free to contact me. I'm gonna be here around. This is my website, LinkedIn, GitHub, and don't feel shy to ask questions, especially about the courses. I'm here for you. And that's pretty, just remember 2 things, or maybe more. So I found uncertainty really important and really nice. How to quantify this thing is we all deal with uncertainty in life, right? And also optimization. So you want to act in such a way which is optimized, right? So that's a good field, I would say. And yeah, just before starting, maybe have some tips is to maybe look at calculus again, linear algebra. You're gonna deal always with these things, but you're gonna make it, right? That's all.
And I will quickly switch to the second student, so he can also describe his experience here in Padova, and then we can have a quick question and answer session. Yeah? So, thank you very much for being here. So start by talking about yourself, and then tell us something about your experience.
Hello, my name is Padova Courses. I'm coming from Iran. I'm actually national students. Professor Rinaldo invited me to share my experience with you, but since I'm the first year student, I didn't provide some presentation. And I wanted to say just something about the course that based on my experience during this year. First of all, I wanted to say that I'm coming from a different background from engineering. I didn't know anything about the machine learning, about the data analysis, but during the last year, it was really a good experience for me since we had a lot of good courses and a lot of good professors that explain everything very well. And another thing is that all the people that presented something here, they were speaking about something related to machine learning. But since I'm also interested in some topics related to economics or business. The data science is not just machine learning. There are 4 different paths in the data science. You can choose between among them. And my path already is machine learning, but in the second semester, based on the courses that I had, I was interested to change my path to something related to economic. And in that area, it's not, I mean, it's common. You have to know about the machine learning if you wanted to go for each of these paths, but the machine learning or some statistical analysis is the common topics among the different paths, but maybe you have to consider your background and your interesting topics to pick your path. Since when I choose my path to machine learning, I was interested to something related to computer visions, but by taking some course, I changed my mind. But actually, during the last year, as an international student that I lived in the Padova, I'm really happy that I'm here, since the Padova is really a student's city. You can find a lot of friends for yourself, and also you can enjoy from your courses. I'm already past just 5 courses, and I have 5 courses in this semester. There are really interesting courses like machine learning, the deep learning, optimization, statistical, and the mathematics for finance, which the mathematics for finance is most interesting topic for me in this semester, but I don't know what's going to happen in the next semester with the courses that I want to take. But yes, this is the all things that I wanted to share with you.
Thank you both for being here today. So even if they had to work on thesis and exams, I'm accepted to be here today and describe you their experience here with us. So in case you have any question, I have a couple of minutes. You can just feel free to ask. Otherwise, you can discuss with them at the end of this event. Any question? Right. So if not, I can switch to the last part. And before switching to the last part, I would thank again our students. Let's switch to the last part. So I'm going to start talking about the data science program. And then Professor Ersege will talk about the internship program in the data science in our master's program. Okay, so first of all, as I said, I am the coordinator of this master's degree, and today I'm going to quickly describe you some details related to this master's degree. And of course, as I said before, also in this case, if you have any question at the end of this presentation or at the end of the event, feel free to ask. For those at home, feel free to send me an email in the next days and feel free to ask any question you have. Okay, so let's start with big data. I mean, right now, at this point, we already know something about big data thanks to the presentations that we had. Well, and this big data is a key term to our contemporary world, and the reason why we have this is just because nowadays we have a limitless amounts of data that are collected, managed, analyzed, and processed every day. Okay, and so this is the reason why we really need a new breed of experts that we now call data scientists. And data scientists basically deals with these big data. And data scientists basically process the data to get valuable information from for the decision-making process. So to help people making decisions by properly analyzing the data, handling and analyzing the data. Right? So this is the reason why we now need a new multidisciplinary learning path in the universities. And this is the reason why a few years ago here in Padova we started this new program. Because we really need new experts that on the one side they have technical skills coming from engineering, computer science, statistics, and mathematics. And on the other side, they have a good knowledge of the specific fields they are working on, okay? The field that is related to the collected data that these data scientists need to handle in the end, okay? And so what about our data science master's course here at UniPD? Well, in 2016, we established this program, and this was basically possible thanks to a collaboration between 5 departments here in Padova: the Department of Mathematics, the Department of Statistics, Information Engineering, General Psychology, and Biomedical Sciences, and the Bruno Kessler Foundation in Trento. So people worked hard and built up this nice program that now is really successful, and so we should be really thankful with these guys. And so the master's degree right now is highly interdisciplinary and is fully taught in English, and I would say by internationally established researchers and professors. Okay. So let's talk about main features. Our study path basically qualifies students to build and analyze structured model for the representation of concrete applications. It also qualifies to properly choose or develop methods for the handling of those models. I've seen some examples today to get a deeper understanding of tailored techniques for data analysis, and to combine and redevelop all those tools in order to solve complex systems in the end. Right? So to solve complex problems coming from complex systems in the end. Right? So our main goal here at UniPD is in this master's program is building data sciences with a solid technical background, a multidisciplinary preparation in various fields where big data emerge, and the ability to properly analyze this big data and provide managers and stakeholders with a clear account of the results. Okay, right now, I must say our data scientists, I'm happy to say that our data scientists are highly required by industries, consulting companies, and public institutions. Okay? And now I give you some more details about this program. And Luca spoiled a bit, so you already know that there are 4 curricula. And in the first year's courses, what you get are some fundamentals related to mathematics, statistics, and computer science. And then you also have plenty of advanced courses where theories and tools find a practical application, like biological data, human, cognitive, and social data, economic and financial data, so that you can really touch with your hand how to properly deal with the real world applications. And then in the last semester of this study path, you have an internship, and Professor Erseger will describe in depth this specific point. And this internship can be carried out in a private company or in a research institution. And you have in here the data science master's degree webpage. You can find all the details related to the programming on the website. And of course, as I said before, in case you have some more questions, just ask. Don't be shy here to answer your questions. Okay. About requirements, of course, you need the bachelor diploma. So with the proven skills in mathematics and computer science, the details are again available on the website. And of course, there are some language requirements. We need the B2 level or something equivalent. Okay? And these are our 4 curricula. We first have mathematics of data science, where the mathematical side is of data science is explored. Then we have biological data analytics, where you mainly deal with biological data. Then we have our machine learning and intelligent systems path, where you learn how to properly deal with machine and deep learning, and you learn how to use and also develop those tools. And finally, you have cognitive, social and economic data analytics. In this case, what you do is learning how to properly deal with cognitive, social, and economic data. Okay? All our curricula are conceived as multidisciplinary platforms that enable you guys to handle data science and data science models and methods properly. And they also allow you to understand the way all those tools are intertwined in big data applications. And of course, we also have, as the students mentioned, plenty of projects and homework that allow you to develop project management and analytical skills. And of course, the partnerships we have with industries and research institutions, both in Italy and abroad, enable you guys to implement tailored techniques in the solution of very exciting data science applications. Here are some details related to the exams we have in this program. These are basically the foundation divided into different areas. We have exam in the mathematics and statistics area. Then we have computer science. And finally, we have biology, economics, human and social science. And of course, we also have some more exams that allow you to get a deeper and deeper understanding of the data science field. And of course, you also have the chance to choose 2 elective exams in these lists, or also in some other courses that are offered at UniPD. Okay? And we also have plenty of research opportunities. You can check them out also in our data science website. We have partnerships with PhDs, with some important research centers like the Bruno Kessler Foundation, the Gran Sasso Science Institute, and so on and so forth. After these 2 years, you guys will be able to represent, compress, and store huge data sets, to develop suitable models to recognize and analyze data, to understand and actually also properly develop methods and algorithms for the handling of big data models, and also to tackle advanced problem applications based on current research. This is the best point in my opinion, because in plenty of courses you will have the chance to touch with your hands what's going on with the current research. Yeah? And of course, there are plenty of employment prospects. As we said, you will easily find a job with companies and research institutions that deal with big data in ICT, finance, transportation, communications, biology, and healthcare. And what I can tell you is that basically almost all the students we have, before they even finish the internship, they get a job offer from the company they work with. So if you work well and if you work hard, you're gonna get your job even before you finish this master's program. Yeah? And the reason why this happens is that our graduates really get a deep knowledge of data science tools and a good ability to deal with the computational challenges behind data-driven systems. And so they really become an effective and an attractive professional profile that easily finds an excellent placement in the job market. So again, I invite you to check our website out. There are plenty of info in case you want to know something more about our program. And of course, if you have any question, feel free to send an email to our administrative staff or directly to me if you want. And we also have a Facebook page, Instagram page. You can check them out as well. They are young, we are cool. So if you have any question and answer, feel free to ask. Maybe at the end, because we still have the second part that, of our presentation that is related to the internship. So I will leave the room to Professor Ercege. And but before doing that, I think we should end presentation.
Coding sheet.
PDF? PowerPoint.
No coding.
So, thanks so much.
Thanks to you. So, hello everybody. Should I?
You have to share before.
Yeah.
So every time you get out, you can share.
Which one? This one.
Yeah, like this.
Okay. Just a second. Let's see how to deal with this. How to have the. Okay, there it is. Okay. Hello, everybody. I'm Tommaso Ercege. I'm the responsible for internships at data science. So just a quick overview about the internships here. So what's the internship? As Francesco told you, the internship is compulsory. So you have to take it, and the internship is going to be, as this definition says, a period of work orientation and training. So the idea is that you're gonna be working on something you've learned and put it in practice. Of course, the activity of the internship should be coherent with what you learned during the course, but there's plenty of opportunities out there because actually data science is a very up-to-date subject nowadays, which is very much required throughout the world. So why an internship? Well, of course, because you need to develop new skills. I mean, you will be facing with a real problem instead of, if you want, more abstract problems linked to what you would do during the courses, and you also come into contact with daily working environment, and in general, you will strengthen your curriculum. So having an internship in your curriculum is in a way a plus. So it is something that is really useful to you, maybe also to lead you from the university world, maybe to the working environment, or to the research environment, in which case you would like to continue studying and being inside an academic institution. So when and how long is the internship? Well, the internship is worth 15 credits, formally 375 hours, which means 3 months, say. And formally, you should do it in the second year. So first you do your exams, and then you apply what you learned during the exams during the internship. But this is not compulsory. There are cases in which the internship can be somehow moved, for example, to the first semester of the second year. Typically, you will combine the internship with the thesis. So internship is 15 credits, thesis is 15. You put them all together in 30 credits.
and 30 credits is the last semester. So you do a work which is a joint work of internship and thesis. So you will try to apply what you learn, do it for real, and then write a thesis on what you have done for real. And well, okay, technically, the way to separate things between thesis and internship is to declare that the internship is, if you want, the more applied part of what you're doing. So, or more applicative part, data collection, programming, test cases, and so on and so forth. While the more, if you want, theoretical part can be somehow linked to what you do during your thesis. So typically you will think of thesis and internship as a whole, which you do in your last semester. 3 semesters of exams, and then right into the final thesis and internship. Where can you take your internship? Well, everywhere. In Italy or abroad, doesn't make any difference. In a company, in a research center, in a university lab, which could also be a university lab of the University of Padova, or a university lab elsewhere. And the main point is that you should look for the internship, or better, for the internship that is good for you. Because we have many contacts which are available through the website of data science, where there's also internship offers at from the career service at UniPD. You will find many there. And there's further a meeting day where companies are invited and research labs are invited here in Padova to tell you about their internship opportunities. This is typically in November. I'll tell you about this in a second. And there's always faculties and instructors. You can talk with them because they have a lot of contacts, and so they may come out with an interesting internship for yourself. But these are the contacts that we at the university have, which are very many, but there's a broad number of other opportunities out there that you can find by yourself, by reading papers or surfing the internet. Well, there's plenty of occasions, or by talking with friends or talking with other students, asking them where they did their internship. And that's also a possibility. I mean, you don't have to be stuck on what we are showing to you as an offer. You can look around to find the internship that best suits you, because it's important. As per the thesis, it's important that you choose an internship that you really like, or a thesis that you really like. So you put all your effort in there, and at the end, it will be gratifying work, and the output, and if you want final output of what you will doing will be better if you go for something that you really like. What's the info day? Students meet companies, typically in November. We'll be organizing also one this year. This is the list of the internship possibilities available. So you can see many companies and research centers from Italy, but also from all over the world. Czech Technical University in Prague, and for example, it's an example. So you will have the chance to be in contact with a few possibilities for internship, but still there's more. And this is a list of places where students in the last couple of years or so have been for their internships. As you can see, there's a few which are based in Padova, PD, others which are based in Italy, IT, others which are based anywhere else in the world, so in Europe, but also in the USA. So, I mean, you can choose to have your internship whenever you really want. Of course, added to this, well, there's also the opportunity of spending an internship in a lab at the University of Padova, which is not listed here, but it's a possibility. So to wrap up, how you do with your internship? Well, you find your company, your research center, either through the links we're providing, or by yourself, so by your contacts. Find an academic supervisor, because you will need, well, the company and the supervisor locally, and then submit a training project to start your internship. At the end of the internship, you'll be awarded your 15 credits. And we've been working to somehow lighten the bureaucratic procedure here. So we hope you'll find a very easy procedure next year. One important thing to know is, can you get paid during your internship? Yes, of course. But this is to be contracted with the receiving organization. So ask for a pay or a reimbursement. There's always a possibility there. Because, I mean, at the end, you know very many things you learn at the university. You are there for putting them in practice. So you're working for them. So they're gonna pay you if you ask. So please ask. Another opportunity, which is indirectly linked to the internship, is spending an internship and thesis through the Erasmus Plus project, which is some opportunities if you're going in Europe to another university in Europe. And one important thing to know is that you can spend your Erasmus, so your semester in Erasmus, and you can also spend a second semester in Erasmus Plus for internship. So ideally, you could be spending an entire year in Erasmus. This is a possibility you have to take into account. This is a paid possibility, paid by the European Commission, and you can also get a salary if you ask the institution where you go. The difference with the standard internship is that there's an open call for this, which typically is in July and September. So you have to apply to the call. But keep in mind that this is a possibility. A little bit of statistics, which somehow relate to what Francesco was telling you before. So see percentages of internships spent in Italy or abroad, 30% in Italy, 60% abroad. This is from 1920, but it's similar in the other years. Did you receive a job offer? More than 60% they received something between similar to 70% they received a job offer, and 30% they did not receive, but most of those 30% were spending their internship at the university, and the university cannot provide a job offer, which means that whenever you're doing an internship, well, the chance of getting a job offer is very high. So it's important that you select your internship wisely. Go and spend your internship in a place where you might be interested in receiving a job offer. What about satisfaction? Well, most of the people are highly satisfied with their internship, some are not. And this is a very important message to you all. When you select your internship, you have to select an internship that suits you. Do not accept internships that do not suit you, because it's important. It's, if you want, the way through university from university toward the job world. So it's important to select it wisely. You can do it. I mean, everybody, well, a lot of students have done it and have done it successfully. So remember this. The internship is, if you want, an important step in your career and in your master that gives you the possibility of getting a direct link with what will be next, either job opportunity or working in academy. It's the same. You spend a period somewhere and then you might be enrolled from there. Okay, so this is very important, fundamental. Put all your effort in finding the right internship for you. And that's it. And that's it. If you have questions, well, obviously, the internship are managed, if you want, by the University Career Service. But here there's me and Laura Provasi also on the technical side to provide, on the, administrative side, to provide you any answer to question you might have. So that's it for this part.
All the presentations we had. So before we finish this open day, I would like to ask you if you have any questions related to the data science master's program, or some question about the internship program. Feel free to ask before we go home. I mean, in case we can also discuss after the end of this meeting. So it's up to you. Any question? Remark? So if not, so thanks for being here, and then let us thank again all the speakers of this day. Back home, in case you have any question, just feel free to send an email to me or to the data science email. Okay, so thanks again, and hopefully see you soon.